Welcome to AI Unboxed Episode 4, Analyst Insights, where data, research, and real-world experience come together to reveal what's next for the AI industry. Recent industry research shows that accelerating machine learning runtimes and improving workload reliability are now among the most critical priorities for AI operators, right alongside managing power, cost, and infrastructure constraints. In this episode, we'll share key findings from a recent study of AI cluster networking operators, offering a first-hand look at how today's AI infrastructures are evolving and where they're headed next. You'll hear how hyperscalers and large-scale operators are optimizing performance, overcoming network bottlenecks, and getting more value from their AI clusters through smarter network design and advanced hypervisor strategies. As always, feel free to drop your questions in the Q&A panel as we go. We have experts moderating chat and answering your questions real time. Mike, over to you.
AI is a dynamic industry. When things change every minute, every hour, and every day, we need to know more than the mere state of the market. We need to know where the market itself is heading. In this keynote, Simon Stanley, an analyst at large at Heavy Reading, explores how industry trends signal a move towards high-speed Ethernet and AI workload emulation, so data center operators can get the very most out of their AI workloads.
So what I'm going to talk about is what's next for AI. So key trends and strategies, and that's really looking at the networking side. But I wanted to, first of all, say a little bit about the state of the market. I think you've heard quite a lot already, so I want to present that in that context. We're certainly seeing a lot of build out of new data centers, also some upgrades as well. And that includes the AI accelerators, XPU, GPUs, and so on, but also the networking. And one of the key things here is that the networking is all about delivering the bandwidth at the lowest latency possible that allows you to build out these AI clusters. And I think that's been discussed already. The AI market's really dynamic, and I think that's something that there was a mention of what's happened in 3 months. Everything is changing. I'm actually familiar with a company that had a very good AI accelerator that wasn't designed for large language models, LLMs. And then when the LLMs came out, suddenly their architecture had the wrong amount of memory in there. So one of the things that's really important in this market is being flexible. So there's new technologies, new techniques, some of the new models, and I think Agentic AI is really adding a new dimension here. There was a talk at the beginning about that, with autonomous AI agents being much more interactive with users, and that actually changes the bandwidths that are needed in the networking. So it has a direct impact on networking. It also tends to have more demanding inference processing. So there has been a view that it's more about the training in terms of building out these large AI clusters, but actually inference is also putting a lot of strain on those AI clusters. And it actually creates new opportunities for using distributed workloads. And that means as you go across, and we talked about scale up, scale out, and scale across, and I'll be talking about those as well. But Agentic AI is much easier to scale across large AI clusters. And scaling really is the key focus of the industry. There was discussion about what can you put in a data center and how can you scale that in terms of power, because power is a major issue in terms of scaling. So we're certainly seeing bigger models, customization of models across more applications, so training models for specific applications rather than just having a generic model. Faster and more reliable results. So there's no point having this big AI infrastructure if you can't rely on the results, if the results don't come in within a time frame that allows you to make use of it. And then larger AI clusters with more efficient AI processing. So how do we make those clusters larger without reducing the effectiveness of the AI models that you're using? So to understand more about some of the key challenges and strategies for AI data center scaling, we wanted to understand what operators were thinking in terms of what their challenges were, what the strategies they're using to make more use of their AI data infrastructure, and also what they're planning to use in terms of networking. So what we did is we partnered with Keysight and conducted a survey of service providers, and that was done during March and April of this year. We received 103 responses from individuals working in various operators, and that was mainly across North America and Europe, with 72% from the larger companies, more than $1 billion. Now, there's another QR code there. The full results are analysed in a heavy reading white paper. That's available to download. I think you will be able to access this presentation later, so you'll be able to access that QR code if you want to look into more details. In terms of the research, we asked a number of questions. I just wanted to give you a flavour for some of the results, but I've also got some detailed results for a few, particularly in the networking space, and some of the strategies that are being used. So one of the things we saw really was that when we asked, what are the key challenges that people are seeing out there, and I think this has already been mentioned before, so budgets, infrastructure limitations, and talent were the things that came out on top. And I think someone mentioned difficulty in recruiting talent. And what we found was that network managers are caught in a capital expenditure crunch. There's a need to upgrade networks. There's a lot of money going into building out new infrastructure, building out new data centers. But at the same time, they need to make the most of what they've already got. And one of the things that's changing as the AI workloads change, the requirements of your network changes. And so you've got to be flexible in terms of how you use your network, and you've got to be able to optimize your network. We also found that operators need to sustain and scale AI infrastructure. So what we found is 90% plus of organizations are either maintaining their existing investment or are growing their investment. So you can see there's an increasing amount of investment going into these data centers. And cloud integration and higher performance GPUs are the leading strategies that people are looking at. And I think the cloud integration is interesting because it then builds into this scale across and how you build out AI clusters and so on. In terms of shaping AI data centers, so we're certainly seeing a need for major network upgrades. We've got some data in one of the subsequent slides on that in terms of scaling up and scaling out, and a number of people have talked about that. Current networking is mainly Ethernet and InfiniBand. 58% are looking at Ultra Ethernet, and I'll say a little bit about why we think Ultra Ethernet is going to be important. And then in terms of optimizing AI data centers, 62% want to get more out of their existing infrastructure. So a lot of what's been talked about is about building out new infrastructure, but a lot of the operators really want to get more out of their existing infrastructure. And I think emulation is going to be important, real-world emulation. 35% said they're already using real-world emulation, and 60% plan to do in the next 3 years. So you can see the majority of operators see that as a key element of their strategy. So just to give you a little bit of detail on the greatest challenges, so budget constraints came out as the top challenge. Also selected was infrastructure limitations and lack of skilled employees, and we already talked about that. But I think scalability and sustainability were also important. So how do you actually manage your data centers? How do you scale them? That's also seen as important. And then hardware failures, and I think that was talked about earlier. So once you have a hardware failure, how do you manage that? And what impact does it have? Does it dramatically reduce the performance of your AI processing? So this next slide, we've seen a similar diagram. I don't want to spend too long on this, but I just wanted to point out a few things. One of the things that's interesting in terms of, we had this chart earlier with scale up, scale out, scale across, and so on. what this is showing is really kind of where we are today. So in the center, you've got the GPUs, XPUs. The connectivity between those is very closely tied to the GPUs. That was mentioned earlier. It's primarily based on copper links at the moment, although there are some solutions that use optical. The scale out is about building these larger AI clusters, but using off-the-shelf Ethernet or InfiniBand optical modules and switches. And that's been quite a focus in terms of reducing the latency. So I think Broadcom were mentioning about some of their switching devices. So new switches that have lower latency, the development of LPO and LRO optical modules, which take out the retimers, so that reduces latency again. But we're also seeing investments going into building out optical switching solutions and Ultra Ethernet as well as a different approach, and we'll talk about that. But it's all about, we've got this scale up, we've got this scale out. How do you build technologies that really connect those GPUs and scale up the bandwidths without increasing the latency? And then exactly where the definition is between these different sorts of networks will change with time. And then above, we've got the front-end network, and that's connected into the wider network in terms of multiple data centers. But as was mentioned earlier, from the scale-out network, you can actually put DCI links going out. So you can have multiple connections between data centers. So what we asked was, what are the network speeds deployed in your AI ML data center infrastructure? And 400G came out as on top, with 55% going for that. 34% said they're deploying 800G. So 800G is getting out there quite quickly, but we're also seeing 1.6T, and that's really primarily in two places at the moment. One is what was talked about earlier, so multiple 400 gig links appearing as a single link. So that gives you 1.6T if there are 400 gig links. But also in the wider network, you can do 1.6T using coherent links now. But I think what we're going to see is people moving quite quickly. So 800G is already there. 1.6T transceivers are starting to come out. People are starting to run trials at 1.6T. So you'll see a move towards that 1.6T, particularly in those back-end networks, fairly quickly, I think. As I mentioned, the question didn't specify exactly where in the network you're running these particular speeds. We did let people opt to select multiple options, so that's why the total is more than 100%. Interestingly, approximately a third of respondents said they're still using 200G, and some were using 100G. So there's obviously room to upgrade those networks to this 800 and subsequently 1.6T. And I think it's interesting, the discussion we had earlier about front-end networks also being upgraded. So you've got these multiple networks that are all running in parallel and may also be connected across multiple racks and multiple data centers. So there's a lot of networking to worry about and optimize. We also asked, in the next 3 years, which networking technologies are you considering? 49% said Ethernet and 38% said InfiniBand. So I think both of those are going to be around for a significant amount of time. 58% said they're considering Ultra Ethernet for deployment in the next 3 years. Now, Ultra Ethernet is interesting because what they've done, there's an Ultra Ethernet consortium that has developed the specification for this, is take the Ethernet physical layer and then put new protocols on top. And these are designed to deliver a very deterministic network, which Ethernet isn't, and also a low latency connection. So that's a new approach. And the question is about standardization. Is how do you build a standardized version of Ethernet that is also low latency and highly deterministic? And I think there's going to be a lot of interest in that going forward. And then the use of SDN. SDN was mentioned very early on in the second presentation today. And 62% that, but that's not a huge surprise, to be honest. So we then asked, what strategies are you using to optimize AI network performance? So when we asked about this, we really saw two sorts of answers in a way. One is involving large amounts of investment, or two of them, so that is network speed upgrades and also GPU upgrades, and they came first and third. Interestingly, in the middle was network configuration tuning, and that was selected by the second highest number of people. So this is actually confirming what I was saying earlier about getting the most out of your existing infrastructure is really important to operators. And 53% said that. And then also seen as important by some was lab cluster testing and optics qualification. And then obviously switch bake-offs to try and get your hardware failures down. Okay, so I mean, that was a fairly quick look through what we've got. As I say, if you want to go into more detail on the results that we've got, then please do have a look at the white paper. AI is a really dynamic market, and we're seeing that with new services, but also new ways of delivering and using AI, and that is having a massive impact on the requirements in the networking. We're also seeing new models coming in as well. AI data centers are key to delivering these services, but the thing to bear in mind, and I think we've talked about this, is it's pushing the boundaries everywhere. So it's new processors, GPUs, whatever they are, it's pushing the boundaries of networking. And when we look back at where networking has come from, there was a time when 100 megabits per second was seen as really quite fast. So, you know, we're now up in the 1.6 terabits per second space. For data centers, it's important to deliver a good return on investment. I mean, that's something that, to some extent, gets lost a little bit. But for operators, it's really important that you actually, once you invest in this infrastructure, that it delivers the best return. And so what we're expecting to see, well, I think more efficient and flexible GPUs and XPUs, and also AI models. And I think the discussion about heterogeneous is interesting. A few years ago, I was expecting to see a number of different solutions for AI acceleration. A significant part of the market has been captured by one vendor, which I don't think is sustainable going through. So we'll see how that develops. Increased use of distributed AI workloads, and I think Agentic AI has a major impact on that, and I think it's a very positive development. A shift to higher speed networks across the AI data centers. We mentioned 800 gig going to 1.6T. We're already developing the solutions for 3.2T. Use of Ultra Ethernet. And there are also other optical network solutions. There are people proposing architectures for optical switching that they're already prototyping that allows you to massively increase the bandwidth of that scale-up network so that it reduces the need for the scale-out network. But then the question is, if you're doing scale across, how does that connect in? So you'll see this all changing as we go forward. And then greater emphasis on data center optimization. I think the real-world emulation will be a key part of that. So thank you. And if you like more details, then please have a look at the white paper. And I'll be around later if you have any questions.
Welcome back. We hope you found Simon's insights helpful as he walked through how AI data center networks are evolving and how operators are planning for what's next. As you heard from Simon, 95% of AI operators are already using or plan to adopt real-world network emulation within the next 3 years, underscoring how critical system-level validation has become as AI infrastructure scales. In this next session, Simon digs a little deeper into what's next for AI data centers, sharing key trends and strategies drawn directly from research with service providers. Michelle, jump in.
Hello and welcome to Keysight. Our guest today is Simon Stanley. He is a renowned analyst for heavy reading, and he's going to be walking us through what's next for AI data centers. looking at key trends and strategies based on survey research compiled from service providers. So hope you enjoy it. Simon, thank you so much for taking time out to sit down with us. I'm going to start with a pretty open question, pretty big one, but you're one of the better people to answer it, definitely. So tell us, how are AI data center networks evolving?
Well, first of all, thanks for inviting me. And what we're seeing is that the large language models and other models that are used for generative AI and agentic AI in terms of the training and also in many cases for inference as well require ever larger AI clusters. These AI clusters have many GPUs or other AI accelerators in them. And the important thing is that these AI clusters are programmed and managed in much the same way as a single GPU. And that then allows the frameworks that are delivering the AI services to scale from a single GPU instance across multiple racks and potentially across our whole data center. So in terms of connecting those GPUs, because obviously they all need to communicate, that connection needs to be very low latency, it needs to be high bandwidth. And at the moment, what we're seeing is that is mostly using copper links, so point-to-point links with some switches. But that doesn't scale up particularly well. So outside of that, there's another scale-up network that uses conventional networking, so that's InfiniBand and Ethernet. And that allows you to expand those AI clusters to a larger number of GPUs. And really what's happening at the moment is that operators and the industry is looking very much at how we can build those AI clusters, reduce the latency, increase the bandwidth, increase the size of those AI clusters without really pushing the envelope for the power.
So speaking of speed, what network speeds are being used in AI data centers?
So AI data centers have a number of networks in them, and the front-end network, which is the bit that connects the CPUs that are used in an AI data center out to the wider network and also to each other, that front-end network is very similar to what you see in a conventional data center. So we've seen those networks go from 100 gig to 200 gig and now 400 gig connecting those CPUs together. And we are seeing, in the AI case, higher bandwidth. So we're seeing 800 gig in some deployments today. In terms of the back-end networks, which is this scale-up and scale-out networks, we're seeing higher bandwidth. So we're seeing 800 gig already being deployed by a number of operators, and several companies are already trialing and looking at ways to deploy 1.6T as soon as that technology is available in volume, which is going to be very soon. So we'll see that over the next year. And then we've also got the data center interconnects that are connecting data centers together. And we're already seeing 800 gig on some of those DCI links. And we're starting to see 1.6T being deployed there as well.
So now that we know where we're headed, can you tell us how we're going to get there? More specifically, which networking technologies are likely to be used in future AI data center backend networks?
Right. So in terms of thinking about this, you need to remember this issue of low latency that you need. You also need high bandwidth. And then the third thing that's becoming very important for operators is standardization. So not having a proprietary solution makes things a lot easier in terms of going forward in terms of scaling. At the moment, we have networks within the back-end network, so that scale-out network being Ethernet and also InfiniBand. InfiniBand is inherently lower latency than Ethernet, but it's only manufactured by one silicon manufacturer, so there's some limitations there. Ethernet is much more available, but at the same time, it's not such a low latency. So what we're seeing is developments like LRO and LPO modules where you're taking out the retimers, and that allows you to reduce the latency in a standard Ethernet module. We're also seeing low latency switches coming out. So these are designed specifically for this scale out data center, AI data center application. And then going further, we're also seeing the developments of something called Ultra Ethernet. Now, Ultra Ethernet is a new networking technology. It's built on the Ethernet physical layer, but then on top, you're adding new protocols that build a very low latency, very deterministic network that's ideal for these scale out and scale up applications. And then the other thing we're seeing is some optical switching. So there's one hyperscaler already deploying optical switching. there's a number of companies bringing out different technologies to bring optical switching to this back-end network.
Okay, we're going to zoom out just a bit. Tell us what strategies are operators using to optimize AI network performance?
So I think that there's two things going on in terms of what strategies operators are following. One is building out new data centers, upgrading existing data centers. So that's putting in new GPUs, more GPUs, better networking, building out that network, and looking at the new technologies that we've been talking about that are coming through. The other thing is really about tuning network configuration. So it's looking at what you've already got and how can you get more throughput, how can you get better results on your AI workloads with improved networking. And so part of that is around emulation. So, I mean, that's a very powerful way of looking at the real world performance of data centers and also modeling what they could be improved to. And so when we asked about respondents about that, 95% said they were either already using real world emulation or plan to do so in the next 3 years.
That's incredibly impressive.
Yeah, I think that's a pretty good result.
Tell us, where do you see the future of AI networking going from here?
Okay, so I mean, really, there's three things there. I think first of all, we're seeing this ever-growing investment in AI, and I think you'll see that continuing. So you'll see much more powerful clusters. You'll see much, I wouldn't say larger data centers because they're already pushing the boundaries of power, but more capable data centers within the existing boundaries of a data center. Secondly, we're seeing the latest networking technologies coming out, and the industry is very focused on bringing out these low latency, high bandwidth solutions that will go directly into this AI networking at the back end, so the scale up and scale out networking. And then thirdly, I think the focus will continue to be on getting the most out of their existing investment for operators. So how can you make the most of the networking that you've already got in your data centers and really return the maximum ROI, the maximum return on investment that is possible in this very dynamic market?
Simon, before we wrap this up, I would love for you to go back. You said 95% were interested already using emulation. That's a pretty large number. Can you go into that a little bit more?
Yeah, what we did is we asked them, we gave the people answering the survey three options, and one of them was already using emulation, and 35% said they were already using emulation. And then another 60% said they would do within 3 years. So that's where the 95% comes from. And then there's just 5% who aren't planning to use emulation.
Which begs the question of what are they going to do?
Well, I think they may have a problem, but we'll see.
Yes, we'll see. All right. Well, thank you. This has been enjoyable, Simon. I hope it's been a good experience for you as well. And we really appreciate you coming all the way. You came a long way to join us here at Keysight. So thank you.
Thank you. I've enjoyed it.
That brings us to the close of episode 4 of AI Unboxed. Today's analyst insights highlighted how AI data center networks are evolving and how operators are responding with new strategies to scale performance, reliability, and ROI. We hope you found these insights helpful as you think about what's next for your own AI infrastructure. We are seeing a number of thoughtful questions in the chat. Although we may not be able to address all of them during today's session, our experts will follow up with you via email. Thank you for joining us, and be sure to tune in next week for our last episode of AI Unboxed, where we are bringing together industry leaders for a panel discussion on one of the biggest challenges in AI right now: how to scale infrastructure to optimize performance.